Hello my students, your physics teacher with you again, Hassan Darwish. In the last video 2, I explained fission reaction. In this video, I will explain something called the nuclear fusion reaction. Okay? The opposite of fission reaction. Now let's see the meaning of fusion reaction. You remember in fission reaction we have heavy nucleus, usually uranium, splits into two lighter nuclei upon the impact of a thermal, slow neutron. Now let's see what the fusion reaction is. Look here in this reaction we have two hydrogen isotopes, means we have two light nuclei. They make collision, they collide with each other to produce a heavier nucleus. Clear? So in this reaction, two small nuclei, usually hydrogen, light nuclei, combine together, make collision and then combine together to produce a heavier nucleus, here helium, with a huge amount of energy. Look, this is the hydrogen bomb. You see? That's the fusion reaction. In reality, fusion reaction is only used in producing hydrogen bombs, where a hydrogen bomb like the one you've seen in the video is almost 1,000th atomic bomb of Hiroshima. Okay? So nuclear fusion produces a huge amount of energy. Okay? So here it is. We have deuterium here, hydrogen isotope, and tritium, also another hydrogen isotope. Not only, this reaction is not only confined or reserved for deuterium and tritium. You may have any two hydrogen nuclei, collide together to produce heavier nucleus. In this reaction it produces helium, which is heavier than this nucleus and a neutron, but with a huge amount of energy. So this is by heart. Also, definition of fusion reaction is a stimulated nuclear reaction that consists in the binding of two light nuclei, two small nuclei, to form what? Heavier nucleus. So this is a definition of fusion by heart. You see, fusion reaction is opposite to fission reaction. In fission, heavy nucleus splits into two lighter nuclei. Fusion, two light nuclei combine to form heavier nucleus. They are opposite. And this definition by heart. Clear? Now, we need the condition to produce fusion reaction. Where usually fusion reaction occurs in the core of the sun, in the core of stars. Why? Because the temperature there is about a few millions degrees Celsius, or about 10 to the power 8 Kelvin. So as an example, here we have deuterium and tritium produce helium and a neutron. So look here, 2 plus 3 equal 5. 4 plus 1 equal 5. 1 plus 1, 2. 2 plus 0, 2. So mass number conserved, atomic number conserved. Here we have deuterium plus deuterium. They produce tritium and a hydrogen. Also this is fusion reaction. Two light nuclei produce heavier, this is heavier than this and that, heavier nucleus. Okay? Now condition of fusion reaction also, we learn this by heart. So this number and this number by heart. Why by heart? We need such a very high temperature because to overcome the positive charge of the nucleus, because positive and positive repel each other. So each nucleus here is positive. If you want to combine them, then the positive charges will repel. So to overcome this repulsion, you need this very high kinetic energy of each one, or you need this very high temperature which exists in the core of the sun. Okay? That's everything about the chapter. See you in next videos. Take care. Bye bye.